And hello guys, welcome to another Cape Stunts video. So, I'm back with another physics video. I'm going to be showing you guys the physics behind precision jumping and jumping as far as you can. So recently we've been posting a few videos about distance and impact and jumping and so on, like Hudson's video about how to maximize your precision jump. Now I will be referencing this video in some of the different steps, so just check it out over here. It's really good. I would seriously recommend this video. As you should know, whenever you're doing parkour, you always want to land on the balls of your feet. Hudson referred to this in his video in the last step of maximizing your precision jump. When you land, you must always land on the balls of your feet to soften the impact. You also do this when you're doing backflips, because you want to make as quiet a landing as possible. The reason you do this is because when you land on the balls of your feet, you can maximize the impact time, slowing you down, because you're adding another joint to the pivotal system that slows down your impact at your ankle. Take these two clips over here for instance. In this one, I landed on the balls of my feet, but if you can see this one, I actually kept on going. So I will refer to this in the last step. So I'm going to break up precision jumping into 3 steps, or 4 steps. So number 1 is your trajectory that you want. The trajectory traced by your hips, then the takeoff, in the air, and landing. Whoops. So number 1, the trajectory. Now this is for flat jumping. Now this is a bit of a difficult topic to cover. I'm going to do it as best I can. So just so you know guys, the trajectory that I'm talking about is basically the line traced by your hips, which is more or less your center of mass, or your center of weight, your center of gravity, however you want to call it. As you should have figured out, if you want to get your maximum precision distance, you want to jump at a 45-degree angle. Not like there, probably about 20 or even right up. That won't work at all. As Hudson was saying in his video, if you don't lean forward, in other words, if you jump too much up, you won't get any distance. Whereas if you go like this, your trajectory height, peak, will be very low. And this will also decrease the distance that you can achieve. So what you ideally want is something between 50 degrees and 45 degrees. Now you might be saying, well, isn't it 45 degrees? Because there's many proofs that 45 degrees for a ballistic flight trajectory can obtain a maximum distance by the projectile. Basically, if something is being launched at 45 degrees, it can achieve its longest distance possible. But actually, because of our human muscle structure and the way that our center of mass is, it's actually a little bit above, so like 5 to 10 degrees above 45 degrees. So you ideally want to get a little bit higher in your jump. Now it's a bit difficult to get this exactly right, but just try to get it. You can even film yourself and see more or less what your angle is of your takeoff. If you want to jump up, you must be careful to not jump directly at the surface that you're jumping on. If you check over here, I actually jump and I start coming a little bit down with my trajectory. If you jump straight at an object, you're going to bash your knees. You're not even going to get onto your object because your hips will be in line with the height of your object. So you're jumping up and you get to over there. and your feet are like here, your head is here, your hips are right level with the thing you're jumping onto. So you want to jump a little bit above so that you can get your feet on. Now this is if you're doing like a standing box jump. If you're jumping down, obviously there's a lot of impact that's required and the risk is quite high. You want to try and calculate that you can do the jump before you actually attempt it, because it can go really wrong. If you can do the distance on flat, every centimeter approximately equals to about half a centimeter distance that you can get with the same amount of force. Now when you're jumping down, you want to get a pretty low trajectory starting off, because this is not the start of the trajectory, but actually where it intersects with your starting off point. So you want to kind of crouch down and then lean forward and then do it, your jump. So now I'm going to show you the physics behind the fail. So this parkour move, I did it in my youth. Now this was at a church, and I did basically a concrete from a bench onto a wall. On my third attempt, or my fourth attempt, I failed. I kept on going, my heels hit the wall and I just kept on sliding. Now this was two reasons. Number one, I mentioned earlier, I didn't land with the balls of my feet, I landed completely with my heel on the object. Second thing is, my trajectory of my hips, my center of mass, was very flat. If you check this video over here, you might be able to notice that my trajectory was a bit more higher. I managed to tuck in my knees to my chest and lift my chest up so that I could start rotating myself so that I could land up properly and stick it. Okay, point number two, this taking off. Now the first thing I want to address is that you want to start off with your feet more or less hip width apart. If you start off with your feet very close together, this is a little setback in the maximum distance that you could achieve with your feet wide apart. If you start with your feet close together like this, it can result in about more or less 10 centimeters of distance lost because of that. So you ideally want to start off with your legs directly underneath your hips. Point number three, in the air. So when you're in the air, you'll notice once you've swung your arms forward for the pre, they kind of go backwards. This is because they're counteracting the torsion force created by your center of mass, basically keeping you upright so that you can land properly. Now also, like what Hudson said, you need to be able to control this. You need to be able to know where your arms must be in the jump so that you can get it right. Also your tuck. Basically, you want to bring your legs up to your chest and then out where you can see them to land. You have to be able to see where your feet are, because otherwise you won't be able to get the proper landing position. Now the last part is how you land. So the first thing I want to address in this step is your angle of incidence. Basically the angle at which you start interacting with an object. In this case, guys, sorry about that. Phone's space right now, so I need to quickly go free up some more. So because of the time difference, it was darker when I finished filming. Is your angle of incidence. Basically the angle at which you start interacting with an object. In this case, the surface that you're landing on. The proper angle of incidence is also more or less 45 degrees and above, between 45 and 50. This provides equal part friction and equal part motion force, normal force, which slows you down and creates this balanced stop. As mentioned earlier in this video, you also want to land with your toes first. If you land on the balls of your feet, you're able to add your ankle to the slowing down system of all the joints and stuff. Basically, if you land with your heel and your whole foot on the object, you won't be able to slow yourself down as efficiently. I landed with my whole foot on the wall. I wasn't able to bend my ankle, I wasn't able to get my heel underneath the lip and use that edge to help me come to a stop, and I kept on going. Now, I was actually fine. I managed to push myself away from the wall and hit the ground when I landed, so I didn't actually hurt myself. But it's definitely a lesson to learn for everybody out there. But yeah, thank you guys for watching. Remember to subscribe, it's really helpful, it helps us out a lot. And check out our other videos over here. Jethro is also posting some parkour shorts, so you can check this first one out over here. Hudson also made a really awesome parkour in the rain video. Now this is really cool. I suggest going to watch this. Also in the right hand corner over here. If you want to watch some more physics behind the parkour moves, then I've got a playlist up here that you can also watch. Catch you next one, guys.
Nate, Jethro, Hudson.